Jmath.
This is a video with the most basic grade 12 probability questions. Please pause in front of each question, try it, and then when you think you got it, check the explanation and the marking to see if you need to revise a little bit or if you are good for exams. Question 1, consider the word proteas. So I can see 7 different letters there. Question 1, how many different arrangements are possible if the letters may repeat? Okay, so remember the theory we did. If it can be repeated, 7 letters, 7 spaces. So the answer is just 7 to the power 7. And that is a massive number. So 8, 2, 3, 5, 4, 3. 823,543 different options if I can use anything and it may be repeated. Question 2, how many 5-letter arrangements are possible if the letters may repeat? So once again, my base is the amount of options, my exponent is the amount of spaces. That now goes all the way down to 16,807. Question 3, how many arrangements, so all 7, are possible if the letters may not repeat? Okay, so I have 7 options then, 6, 5, 4, 3, 2, and 1, because each time I put one down, I cannot use it again, and that represents 7 factorial. So if I type that on my calculator, the answer is just 5,040 different options. Now they're telling me how many 5-letter arrangements are possible if the letters may not be repeated. So I'm just taking those 2 away. So remember, I can write that as 7 factorial divided by the ones I do not use, or you can just say it is all of those just multiplied. It means exactly the same thing, and the answer would be 2520, so 2,520 different options for that scenario. Okay, question 5. How many arrangements are possible if the first and the last letter must be a vowel and letters may not be repeated? Okay, so let's just sketch that scenario. So I have 7 spaces again, and now they're telling me the first and the last one can only be a vowel. So that's the O, the E, and the A, and for the last space as well. So I'm just looking at the word proteas, and those are my only options. Now, because it may not be repeated, I have 3 options for the first one, but if I choose one of them, I cannot choose it again for the last space. So that's why my first space would be 3 options. My last space would then only be 2 options. So I don't know which one I'm going to choose first, but if I chose it, then I can't choose it again for the last space. All the ones in the middle is what is left over. So out of the 7, I've now chosen 2 spaces. So therefore, this would be 5 options left, then 4, then 3, then 2, then 1. So if I multiply that, the answer to this question is just 720 different variations. Question 6, what is the probability that the arrangement starts and ends with a vowel and letters cannot repeat? Okay, so it's exactly the same question as question 5, except the word probability is now mentioned. So I'm going to take the answer for question 5, so 720, and I must just divide it by the total when the things may not be repeated. So question 3's answer, so 5040, which is actually just 1/7. Each of these questions would count 2 marks, so 1 for your working out, so is it an exponent or a factorial sum, and then 1 for actually writing the answer. I think question 5 might be an extra mark, just because it was a bit more complicated than the rest. Question 2, the South African lottery machine has 49 balls, and every week 6 plus 1 because of Powerball, so 7 are chosen at random. What is the probability of a person winning if they buy 100 unique tickets? Okay, so sounds complicated, but remember, I have all the options for the first space. Then it just goes down by 1 each time. So I'm just going to start with 49 and then write it all the way till I get to the last space. So if I work this out, that would be all the possible combinations. I can now work out that specific sum if I just put multipliers in between, or I can say it is 49 factorial divided by the ones that I do not pick each week. That answer is now massive. So 432,938,943,360. Okay, guys, so that is, in America, that would be 432,938,943,360 different tickets you need to buy to ensure that you hit the jackpot for sure. Okay, now the question says, if this person buys 100 unique tickets. Now remember, if they choose a combination, they are only choosing one of that 4.3 billion options. This person's buying 100 tickets, so the probability of them winning is now just 100 over that massive number. Okay, so I do not need to do a sum for his options and the numbers he's picking or whatever, because he is just buying 100 separate tickets. So I'm not going to work out each one of the 100. I'm just going to say 100 of those tickets will be his probability to hit the jackpot. Lacquer confusing, if you ask me. This question would count 3 marks, so 1 for your method, 1 for your answer, and then 1 for the probability. Question 3, a private university can accommodate 5 master students per year. If 20 apply, in how many different ways can the 5 spots be filled? So for the first spot, they have 20 people to consider. If they've chosen one of them, then they have 19 people left, and so on until all the spaces are filled. So I can either just type in that, or I can say it's 20 factorial divided by everybody who did not get chosen in this year, and that would be 20 factorial over 15 factorial. And the answer is 1,860,480 different combinations and how they can fill those 5 spaces. This question once again just be 2 marks, 1 for the method, 1 for the answer. Question 4. So this comes from a government exam, a November final exam. I can't remember which year, but it was quite a few years ago. How many possible 10-digit phone numbers could be formed? So now they give you lots of restrictions, and we must now just figure out what can be in which space, and then tell them how many there are. So you can read the question up there and how they limit you. So the area code can be 3 digits, okay, no restrictions. Then the exchange code is 3 digits, and then the last one are 4 digits. Now they're not telling you which numbers are possible where, they're just telling me how many there are. So it's 10 different spaces, 10 different options. So the answer for question 10.1 is just 10 to the power 10. Now they're starting with the restrictions. So certain restrictions were placed on the groups. The area code must contain 3 digits, and the first digit cannot be a 0 or a 1. So let's just draw that out to see how many options I have for each space. So now they're telling me the first digit cannot be a 0 or a 1. That gives me 8 different possibilities for the first spot. So that's going to be an 8 because it cannot be 0 and it cannot be 1. Now they're not telling me about the other 2, so I can say that's a 10 and that's a 10. And I'm just multiplying. Now, exchange code must be 3 digits, and the first and second digits cannot be 0 or 1. So this is 8 again, and this is then a 10. Now, for the last one, the number must be 4 digits, and the first digit must be a 0 or a 1. So that is 2 possibilities there, and the rest, they did not say anything, so that's all 10 possibilities again. And if I type that whole multiplication sum in my calculator, I get this is 1024 and then 60. So now question 10.2.2, determine the probability that any randomly chosen 10-digit telephone number would be a valid phone number. Okay, so it sounds complicated, but I now worked out both variations. So I worked out how many options are possible if I comply with the restrictions. I know that all the possibility was 10 billion. If I just divide those 2 answers, I'm going to get the answer to the question. And this probability is 64 over 625, or you could just say it's 0.1024 probability chance of getting a valid telephone number. Here is the official memo. Please check if you would have gotten full marks for this question. Okay, guys, so that was the official exam paper, and 7 marks for the grade 12 probability. In another year, this was the November probability question, and for 6 marks, let's see what you needed to do. Motors Incorporated manufactures cars with 5 different body styles, 4 different interior colors, and 6 different exterior colors, as indicated in this table. The interior color of the car must not be the same as the exterior color. Okay, so it's way back to the first things we did, where I'm just going to see how many options there are in each different choice, and I'm just going to multiply. So Motors Incorporated wants to display one of each possible variation of their cars, but the showroom is only 500 square meters, and each car requires 5 square meters. Is this display possible? So we need to figure out how many different options are there. Then we need to figure out, will it fit into their showroom? So let's go. There are 5 different body styles to choose from. Then there are 4 different colors, and for the exterior colors, there are 6 different options. Okay, now it's a 6-mark question, so it will definitely not be as easy as that. So let's now just see why is it a bit more complicated. Okay, so unfortunately, this top one will not work. There are restrictions, and I need to compensate for each variation. So I know that there are 5 body styles. They do not tell me what it is, so I do not care if it duplicates or not. But now, with the interior colors, it cannot be exactly the same as the exterior colors. And now, if I look at the list they gave me, there are blue options in interior and exterior, as well as red options in both. So I am going to do 3 separate variations to the question, and I'm going to add those 3 answers. So the first one would be if I say I am choosing blue for the second space. Then in the final space for exterior colors, I am not allowed to choose blue. So therefore, I am saying there are 5 options left because I took blue out of the equation. With the other variation, I'm going to say I am choosing red for the middle part, and therefore I cannot choose red for the final part. So that would be a 5 then. The others for gray and black, it doesn't matter. So I'm just going to say there are 2 options there, gray and black, and then all 6 options are valid for the last one. So now I'm just going to work out each one. 25 plus 25, and that would then be plus 60, and that gives me a total of 110 different car variations that are possible for this Motors Incorporated company. But now they're asking me, will it fit on the showroom? So the showroom had 500 meters squared. So that's the limit of how many they can fit in. They're telling me each car takes up 5 square meters of space. So I'm going to take my answer and I'm going to multiply it by 5. That gives me I need 550 meters squared. So to answer their question, no, all variations will not fit in the showroom. Here is the official memo that did exactly what we did, except they split grey and black as well. So they had 4 separate answers that they plussed, and then they had to write the conclusion. How did you do with this one?
If this video helped you, please like and subscribe.
Jmath.